Welcome back to the channel. So today in this video we are going to attempt question number 1 of miscellaneous exercise on chapter 2, that is relations and functions of class 11th CBSE mathematics. So question number 1 is the relation f is defined by f of x is equal to x square when x is greater than or equal to 0 but less than or equal to 3, and 3x when x is greater than or equal to 3 but less than or equal to 10. And the relation g is defined by g of x is equal to x squared when x is greater than or equal to 0 but less than or equal to 2, 3x when x is greater than or equal to 2 but less than or equal to 10. Show that f is a function and g is not a function. So this is question number 1. So first function is f of x is equal to x squared when x is greater than or equal to 0 but less than or equal to 3, and 3 times x when x is greater than or equal to 3 but less than or equal to 10. So here one can observe that f of x is equal to x squared is well defined in x is greater than or equal to 0 but less than or equal to 3, and f of x is equal to 3 times x is also well defined in x greater than or equal to 3 but less than or equal to 10. So here one can observe that for these two functions we have some common value, that is 3. So here we'll be using this value, that is 3, to check whether f is a function or not, because this is a common value and we'll have to find out whether at this very common value we are having same image or different image. If we'll be having same image, then it is a function, and if we'll be having different image, then it's not a function. So at x equal to 3, let us first of all take function f of x equal to x squared, and this will be equal to 3 squared, and that's equal to 9. Now again at x equal to 3, let us take function f of x equal to 3 times x. Now here we'll be having 3 times 3, that's equal to 9. So here one can observe that 3 has only one and one image, that is 9. Therefore f is a function. Now let us take g of x. So here we are having g of x equal to x squared when x is greater than or equal to 0 but less than or equal to 2, and 3 times x when x is greater than or equal to 2 but less than or equal to 10. Again, g of x is equal to x squared is well defined in x greater than or equal to 0 but less than or equal to 2, and g of x equal to 3 times x is also well defined in x greater than or equal to 2 but less than or equal to 10. Now here we'll be again considering the common value, that is 2, and check whether this 2 is having same image or different image. Now at x equal to 2, let us take firstly g of x equal to x squared. This will be equal to 2 squared, and that will be equal to 4. Again at x equal to 2, now we'll be taking g of x equal to 3 times x. That will be equal to 3 times 2, and this will be equal to 6. So here one can observe that element 2 is having two images, that is 4 and 6. Which is not possible for a function. So therefore g is not a function, as same element cannot have different images. Towards the next question. Question number 2 is, if f of x is equal to x squared, find f of 1.1 minus f of 1 whole divided by 1.1 minus 1. So in question number 2, we are given with function f of x equal to x squared. Now we'll be putting value of x 1.1 and 1, and then finding the value of this very expression. So first of all, we'll put x equal to 1.1. Then f of 1.1 will be equal to 1.1 whole squared, and this will be equal to 1.21. And now we'll put x equal to 1. So f of 1 will be equal to 1 squared, and that's equal to 1. So therefore our expression, that is f of 1.1 minus f of 1 whole divided by 1.1 minus 1. This will be equal to 1.21 minus 1 whole divided by 1.1 minus 1, and this will be equal to 0.21 over 0.1, and this will be equal to 2.1. So this is our answer. Towards question number 3. Question number 3 is find the domain of the function x squared plus 2 times x plus 1 whole divided by x squared minus a times x plus 12. So this is question number 3. Here the given function is f of x equal to x squared plus 2 times x plus 1 whole divided by x squared minus a times x plus 12. We know that for a function to be defined, denominator cannot be equal to 0. That is, x squared minus a times x plus 12. This cannot be equal to 0. Now after factorizing, we'll be having x squared minus 2 times x minus 6 times x plus 12 is not equal to 0. That implies x times x minus 2 minus 6 times x minus 2 is not equal to 0. That implies x minus 6 times x minus 2 is not equal to 0. And this will imply that x is not equal to 6 and x is not equal to 2. So therefore, domain of this function will be all real numbers minus these two values, that is 2 and 6, because at these two values, the denominator of this function will become equal to 0. So these two values are not possible. Towards the next question, find the domain and the range of the real function f defined by f of x is equal to x minus 1 whole square root. So this is question number 4. So here we are given with a function f of x equal to x minus 1 whole square root. So in order to find the domain and the range of this function, let us plug in the different values of x and see what happens. So here this column will represent values of x. This one will be our function, which is equal to x minus 1 whole square root. And in this column, we'll check whether the output is real or not. Suppose we have value of x as 2. Then our f of x will become square root of 2 minus 1. That will be square root of 1, which is equal to 1, and it is a real number. Similarly, if value of x is 1, we'll be having 1 minus 1, that's equal to square root of 0, that is 0. So this is also a real number. Now for x equal to 0, we'll be having square root of 0 minus 1, that will be equal to square root minus 1, and this one is not a real number. Similarly, for negative 1, we'll be having square root of negative 1 minus 1, and this will be equal to square root of negative 2, which is again not a real number. And for negative 2, we'll be having square root of negative 2 minus 1. This will be equal to square root of negative 3, which again is not a real number. So here one can observe that values of x can be greater than or equal to 1, as at these very points, our output will be a real number. Therefore, domain of this function will be 1 to infinity with 1 included, but infinity, as we know, cannot be included. Now what about range of this function? Here one can observe range, which is output, can be 0 or greater than 0. But below 0, we are having all values which are not real numbers. So range of this function will be 0 to infinity with 0 included, and infinity, as we know, is not included. Now towards question number 5. So question number 5 is find the domain and the range of the real function f defined by f of x is equal to x minus 1 whole modulus, or modulus of x minus 1. So it's question number 5. Here the function is f of x equal to x minus 1 modulus. So here again, to find the domain and range of this function, we'll be plugging in the values of x and find out what the output will be. So here again, this column will represent values of x. This column will represent our function f of x, which is equal to x minus 1 whole modulus. And this column will be used to check whether the output is real or not. So for x equal to 2, we'll be having f of x equal to modulus of 2 minus 1, and this will be equal to modulus of 1 or mod of 1, and that will be equal to 1, which is a real number. Similarly, for value of x equal to 1, we'll be having modulus of 1 minus 1, and that will be equal to 0, which is again a real number. Similarly, for value of x equal to 0, we'll be having modulus of 0 minus 1, and this will be equal to modulus of negative 1, and that will be equal to 1. As we know, the modulus of a number is a positive number. So this again is a real number. Similarly, for value of x equal to negative 1, we'll be having modulus of negative 1 minus 1, and this will be equal to modulus of negative 2, which will be equal to 2. This again is a real number. Similarly, for value of x equal to negative 2, we'll be having modulus of negative 2 minus negative 1, and this will be equal to modulus of negative 3, and that will be equal to 3, which again is a real number. So from this table, we can conclude that the domain of this function will be all real numbers. That is, the values of x, they are all real numbers. So the domain of this function will be all real numbers. And what is range of this function? Here one can observe that all these outputs, they are non-negative real numbers. So the range of this function will be non-negative real numbers. Hope this makes sense. Do subscribe to the channel for more such content, and thanks for watching.